Section 11.1, solving quadratic equations by completing the square. The first couple of examples, they relate to this, but they're not completing the square, the first four. So the square root property, if b is a real number, so b would be a number, just any number that is real. And if a squared equals b, so a would be, then a would be equal to plus minus of the square root of b. So basically it's what we done on a previous lesson, where you take the square root of both sides to cancel the square root and the square, and you end up with this part. So like this. It's when you do the square root, you cancel this, and you end up with plus minus square root of b. So this is what this means, except you don't have to do this. Automatically you can do that because it's already stated here in this property. So I'm gonna do the first four for the first video, and then I'll pause it and do the other ones. So sample 1 would be solve. This is not the right. So use the square root property to solve x squared equals 50. So this is where you have to take the square root or use that property. I'm just gonna do the square root plus minus. So cancel that, and so you end up with x equals plus minus square root of 50. So from here, it's the same thing that we've been doing. You gotta simplify this. You gotta find something that can be simplified. So you gotta find a perfect square root factor that one of those factors is this perfect square root. So it would be 25 times 2 gives you 50, and you know the square root of 25 would be 5. So plus minus square root of 25 is 5, and then square root of 2 stays inside. Okay, so this would be the answer for x. You could check and the plus and minus because we have two options, and they do check. So they do check. I'm not gonna do the check, but you could do it. Maybe let me do it for this one because it's so easy. So I'm just gonna do it this time, because there might be times that, like I said on the previous lesson, that you might have the wrong answer, but one of these answers might not be valid. So you're gonna have the plus, so 5 square root of 2 squared should equal 50, and then the minus. So you're multiplying these twice. So 5 times 5 is 25. Square root of 2 times square root of 2, they're both positives. I'm going to put them inside like this. So 25 square root of 4. So square root of 4 is 2. 25 times 2 would be 50. So like I said, it checks. This would give you the same thing because it just has a negative, but since we're multiplying it twice, the negative goes away and you end up with this. So I'm just going to do 50 equals 50. You're going to end up with the same thing. So they both check. Example 2. So we're still using the square root property. So in order to do that, we need to send this 14 to the other side. So let me start from the edge here. So you would send the 14 to the other side. And then you would divide by 2. And then you would do the square root. So x equals plus and minus square root of 7. And for this one, that would be the answer. You could check again. I'm not gonna check. You could do the check for positive square root of 7 and the check for negative square root of 7. Alright. So let's do example 3. So that would be the answer. And this is the answer for this one. Example 3. So use the square root again. Even though we have a binomial here, you still apply the same. You're gonna take the square root plus minus. Don't forget the plus minus. So x plus 1 equals plus minus square root of 12. And we can actually simplify this. So let's do that. And then I'll move the 1 later. So this will be 4 times 3 equals 12. And I know square root of 4 is the perfect square root. Square root of 4 would be 2, and then the 3 stays inside. And then we still have this 1 to bring over. Plus or minus 2 square root of 3 minus 1. So and again, you could check the whole thing. So you would have to substitute this into this. I'm gonna do it once, just because I see it's a little bit different. So I'm gonna check the positive. So x is this whole thing. So I'm gonna put square root of 3 minus 1, and then plus 1, and then square equals 12. So I'm checking the positive one. I'm checking this one. Positive. So negative 1 plus 1, that one comes 0. And then you have 2 of these things. So 2 times 2 is 4. This 3 times 3 is 9. Square root of 9 is 3. 4 times 3 is 12. So I checked, so both of them check since I have it in the book. So that's the answer. Example 4, this is the last one for this type question. Use the square root property to solve this. So again, we have this, and then we're going to take the square root, so plus minus. So 2x minus 5 plus minus 20. And then once again, let me see if I missed something. So far, what happened here? Oh, I got the wrong number to start with. This, I don't know where the 20 came from, but this should be 16, negative 16. So all of this is wrong. So I'm gonna restart. So again, it shouldn't have been 20, it should have been negative 16. I don't know where I got the 20 from. And then, so negative 16. So now we're gonna do the square root, so plus minus. This goes away, so you end up with 2x minus 5 plus minus square root of negative 16. So again, we have arrived to something that doesn't have a real solution. Square root of a negative does not exist in the real world, so we're going to have to work with complex numbers, imaginary numbers. So plus minus, so remember this becomes -1 times 16. So the square root of -1, let me put the note here, I is equal to the square root of -1. And I squared is equal to -1. In case we need it. Well, we're going to need this one. So this becomes 2x minus 5 plus minus I square root of 16. So this becomes 2x minus 5 plus minus I times square root of 16 would be 4. We don't need this. So 2x minus 5 equals plus minus. I'm going to put the 4 in front and then the I. We still have the 5 here. So I'm going to add 5. Remember when we have this, we need this form. A plus bi. So we need this form. So I'm going to put the number in front and then plus minus 4i. And then we divide. So x equals 5 plus minus 4i over 2. So the answer would be this. And they like to put them separate. Or you can even put it like that. One of them has a negative. I'll take this just so that you guys save time. So those are the answers for this type of question. And that would be it for the first part.